All right, hey AP Calculus, we're going to do some volumes of solids of revolution problems. Here's the first example. Find the volume of the cone created when we revolve the triangular region bounded by y equals negative x plus 1, x equals 0, and y equals 0 around the x-axis. So first thing you want to do is create a Cartesian coordinate plane. And the second thing you're going to want to do is graph y equals negative x plus 1, which is just a linear function. Here. Right, this is the ordered pair 0, 1, and this would be the ordered pair 1, 0. It's a linear function with a slope of negative 1, upward shift to 1. X equals 0, that is the what? The y-axis. And y equals 0, that's the what? The x-axis. So hopefully you're seeing that this is the triangular shape. Now what do we want to do with this triangle? We want to create a cone. How? By taking this triangle and revolving it around the x-axis. So you're going to take a triangle and you're going to spin it on an x-axis. Let me see if I can show that to you. Here's a piece of paper. Obviously it's not a triangle right now, but I can make it into a triangle pretty easily. Okay, make a triangle. All right, I think that will pass as a triangle. If I take this triangle, it's a little big, so I gotta pull this up. If I take this triangle, and here's my x-axis, right? So just right now it's in 2 dimensions, but I allow myself to spin this triangle around here. What do I get? What shape is created? A cone. The cone's facing that way. If I want it to be this triangle just like this, see that shape matches? Watch what happens. You see it? You see where the cone's facing? It's got a little point here and a big circle on this side. So you're going to create a cone. Here's how you do it. If you just draw a reflection of what you originally have, and then just make the mouth of the cone. You can see the big cone now, can't you? It's facing that way. All right, so we're supposed to find the volume of that cone. How do we do it? Now, we have a pre-calculus form we can use, which is just the volume of the cone is equal to 1/3 pi r squared h, which is the same as 1/3 pi. Well, what's the radius of this guy right here? 1. Isn't the radius just 1 from y equals 1 to y equals 0? That's a distance of 1. And then what's the height? Well, the height appears to be 1 also. Do you see that? From 0 to 1, 0 is a distance of 1. So right, we got it. The answer is 1/3 pi units squared. Which is great. Pre-calculus is certainly faster than calculus in these kind of problems. But the problem is you're limited to only these very, very, very pretty shapes you have memorized formulas for, which is it amounts to 4 or 5 shapes in 3-dimensional space. You have to be able to do this for any shape at all. So calculus will always work. Here's what we do. We take out our swords. Remember this? Take out a sword. What can pass as a sword? Over the end of a spoon here. We're going to take our sword and go, yeah, cut this thing right here. Yeah. Cut this right here. And what are you going to get? You're going to get a piece that comes out. That piece has a shape. Can you tell me the shape's name? It is a cylinder. And we call that cylinder a disc. Here, try to draw it like that so you can see it. You see it? It's a disc. Maybe I go like that just to make it clear what it is. The first cut happened right here. The second cut happened right here, and what emerged was a solid disc. That solid disc, we're going to find its volume. Okay, so this was the volume of the whole cone. But we're instead, right now, we're going to be finding the volume of the disc, which is, it's not a sub-rectangle, it's a sub-what? A sub-cylinder? Well, what's the volume of any cylinder? pi r squared h. All right, we need to now define it in terms of x. We want a two-variable equation. So how can we do this? Well, let's look at our guy right here. This right here is our radius. I think you can identify this part as our radius. All right. This radius goes up to some y value up here and down to the y value of 0. So the distance between y up here and y down here is what? Y minus 0 is y. So we got pi times y squared. Now the height. The height here is this right here, right? Just think about the disk as if it was on its side. That would be its height. This is from a first x cut to a second x cut, like x2 minus x1 is that distance. What do we call a change of x in calculus, especially if it's infinitely small? Dx, a small change in x. So the height is dx. So we got pi r squared h. Now, we don't like to have integrals with y dx, we're like x dx. No problem. What was the equation over here for this line right here? Y equals negative x plus 1. That was that linear equation. So can I replace this y with that term? Sure. And what do I get? I get pi times negative x plus 1 squared dx. Well, this is the volume of the cylinder. How many cylinders are going to be adding together? How many of these discs are going to be adding together to get the volume of the cone? An infinite number of them. From where to where? From x equals 0 to x equals 1 over that length. Okay, so here you go. The volume, this was the volume of the disc, but the volume of the whole cone is going to be, not using the pre-calculus formula, using calculus now, we're going to sum up all the volumes of the disks, which we determined to be this formula, pi times negative x plus 1 squared dx. Well, it's an x dx, so from x equals something to x equals something. From x equals 0 to x equals 1. That right there is the volume of the cone. And in the end, it should match up with this guy right here, shouldn't it? Shall we see that? Should we do the math? Yeah, let's do the math. That's probably a good idea. All right, so let me write this as, I could pull the pi out. X equals 0 to x equals 1. Let's factor this guy. There we get x squared minus 2x plus 1 dx. All right, so we got pi times, let's anti-differentiate, you get 1/3 x cubed minus x squared plus x, all evaluated from x equals 0 to x equals 1. So if I plug in 1 here, I'm going to get pi times 1/3 times 1 minus 1 plus 1 minus 0. Right, because I plug in 0 here, this all becomes 0. So that's just 1/3 times pi, which means you get same answer we got here, 1/3 pi units squared.